Ernest here.
I'm Lachlan.
We're Fresh Start Projects, as you guys know. So we're going to do some videos for you guys. We're trying to go down the high performance road, and so we've been trying to gather information, and it's hard to get anything for up here in Canada and Calgary specifically. So we're going to try to make some videos, experiment with some products, and really sort of show people in our area how these products go together, how they're installed, how they perform, the differences between sort of the typical code and sort of this new elevated way of doing things.
So on that note, we decided last week in a crazy cold snap to go and check out a couple jobs that we had done in the past year and just see how some details are performing and what's working and what isn't.
So we're going to start off with one of our houses. So this is a typical sort of builder grade house built in the 80s.
1978.
78, there you go. So nothing fancy, just your typical fiberglass insulation, 2x4 construction, some version of a poly vapor barrier, probably a 3 mil or something like that. More for air control probably than vapor back then. And so yeah, let's look at the clip.
So here we go in our 1978 half duplex. We're 17.5 degrees inside, negative 29.5 outside. So what we can see here is that our attached wall is basically the same as the inside temperature. Makes sense. But we move over to an exterior wall, we are definitely colder.
So one thing we should note, so on this this infrared gun you're looking at here, so the yellow spots are where there's insulation and it's actually performing reasonably well. There are sort of orangey red lines are where the studs are, so that's where your thermal bridging is happening. And then the really blue spots are where there's gaps in the insulation or no insulation whatsoever.
So something interesting with those windows, the fixed windows are in that house are double pane, and the operable ones are technically double pane because there are two separate sliding units in there. But because of the complete lack of air sealing, you can see how much colder those ones show up compared to the standard double pane. Now, the smaller rooms that are separate from the main area do get significantly colder. So with the rooms at the back of this house being colder than the rest, that's kind of an airflow issue that we've seen on lots of different jobs and houses in general. That could be a whole video on its own. A lot of that comes down to managing how much airflow you get in the areas that tend to stay warmer. And sometimes the rooms that are furthest away from the furnace don't get enough, they just don't get enough heat out of the ducts because that's gone before it gets to that point. Yeah, that could be a long conversation by itself, but totally. Just wanted to make note of that. Something that stands out in an older house like this is the really low heel height at the ends of the trusses. So we have 6 degrees there, where the rest of the wall is in the mid-teens, low to mid-teens. That's going to be a tough spot for air leakage and for thermal transfer coming through. What's that?
It's a good spot for air leakage, not a tough, not a tough spot for air leakage.
If you're air, you love that spot.
A lot of the jobs we do are 50s bungalows. Very typical for here in Calgary. There was a whole era of those type of styles of houses where the roofs were stick framed and it wasn't a truss roof. So when you get into a truss roof, it's typically clear span from exterior to exterior. They can build the top and bottom cords independently of one another so they can raise the heel height to get more insulation in, which is typically what they do now. But back in the day, they typically would build, so if you have a wall and you have a ceiling member, they would put the roof on and they would do what we call a bird's mouth in it, basically a notch in the piece of wood like that. So it sit in the exterior corner like that. But the problem is this space right here tends to be around 2 inches, which it's nowhere near enough to get airflow and also R value. So what we tend to do nowadays is we can measure what we can see here. So with a truss roof, you have your trusses. So they typically have a much bigger heel height here. And so now you've got room for anywhere between, you know, sort of 7 inches to, like, we do trusses with 16 inches. So you get lots of room for insulation and also airflow as well. So that's a big issue with these small bungalows, trying to make them more efficient, more airtight and stuff. You either end up having to do what they call a chainsaw retrofit, where you cut off the tail and then you seal this up and then you do exterior insulation on the whole thing. Or we just a lot of times recommend clients just take the roof off, do a truss roof, and just make it way easier on yourself, kind of thing. If you're getting into significant increases in insulation.
And depending on the level of renovation you're doing, if you're taking down lots of interior walls and you have to re-engineer the existing roof that's 70 years old, a lot of the time it's a lot easier and a lot more efficient to just build a new roof. And then you have unlimited floor plan options inside of that package.
Yeah, so there's a lot of pros for that, for sure. So it's a wonderfully cold -35 day here in Calgary. We're going back to a couple of houses we did last year just to kind of see with our infrared gun to see the different assemblies we did and what we're accomplishing. So we're in our Longmore house. So this house is the one with the passive solar windows on the upper section. So I just want to show you guys that it actually works. So that's our wall. And we go up, looks like there's on fire there. So we're actually getting passive solar gain on these 4 transom windows. That's pretty cool to see it actually work. Everyone who has a window in their house gets solar gain in the summer. That's obvious. That's why our houses get so hot, because sun comes in and it just makes your house sweltering hot in the summer. The idea of using passive solar is that you're using overhangs or some kind of natural, a tree or whatever, so that you're letting light in the winter when you want the heat gain, but you're blocking it in the summer. So on that house, what we had was 2 different overhangs on the roof. So this is facing south. So the idea is that this upper section blocks the sun, as you can demonstrate, blocks the sun's angle from in the summer and lets sun in during the winter.
So in the winter, when the sun's nice and low, everything comes right in the windows. This was the spot on the wall that you saw in the video. So that helps heat up the wall, which then in turn helps to heat the house. In the summer, sun's high and it's blocked, at least for the most part, by this overhang. So you're not getting unnecessary heat in your house that you really don't want when it's already hot outside.
So now we're back in front of this house you might recognize from the solar eco solar tour. It's still -35 Celsius outside. So let's go inside and hopefully it's warmer in there. So we're inside. It's nice and warm in here for sure. So I believe the homeowner said the temperature is set at 20 degrees and it's -35 outside still. We've been here for a bit. But we'll show you the wall temperature. So the wall temperature right now is showing 20.3. So in fact, it's probably exactly what the thermostat is set at. You can still see the studs, even though it's insulated on the outside on this wall. But again, air surface temperature is basically bang on with what the house is. So I was quite surprised in this one that we could actually see the studs, even though that wall has 3 layers of 2-inch GPS insulation on the outside. So essentially R30 on the outside of the stud cavity. It's just, I guess the difference is, even though it's not really reading much difference in temperature, it's just the fact that it's still different than the wall cavity insulation is why it's showing up here. But there's R30 on the outside. There's tons of insulation on the outside. So we're not losing any heat there, but it's just a different temperature compared to the stud cavity that has insulation in it. So
yeah. And based on what we could see, the gun wasn't reading a different temperature. It was the same within a fraction of a degree.
Yeah.
But you could see it. But that is very different than my house with 2x4 walls, for example, where you see every stud and it is 2 or 3 degrees colder than the cavity in between.
And so these are those Inotech, it's their Defender series. So it's not passive windows or anything like that. They're just a triple glazed, high performing window. But we'll just go to show you here some of the differences. So these windows were installed with outer insulation as well, or over insulated as they call it. And you can see that the frame temperature here is, so what is that, 15.6, where the over insulation is. And then same with the glass. If we get into the glass here, glass is showing to be about, 16.6. So so the glass temperature is basically the same temperature as the frame on these ones, which that's pretty incredible. Want to just jump in there and say, so you can see all the sun behind me there. I'm not in a halo situation here. It's just this window faces south or west, I think it is. So there's a lot of sun coming through. So I think the temperature here that we're going to get on the window frame and the glass is a little bit skewed because of the sun coming through, but still a significant difference with the over insulation and the non over insulation, basically.
Totally. Yeah, it's worth mentioning that this was far from a scientific experiment. It's just going around and testing stuff to get an idea of how things are performing. The gun we're still working on calibrating it all properly. We had sun in some sections and it was nighttime in others. So we're not too exact with it. Yeah, it's more just to get an idea.
Yeah. This is for information and entertainment purposes only, clearly.
Just entertainment.
Yeah, mostly entertainment. So let's do a little detail here about this, what we mean by outer insulation.
So if this is our Inotech window frame here, we have triple pane glass.
Oh, sorry, yes, front line.
This is our wall assembly here. In this situation, it's Polycore on most of the walls, but this could be a regular wall too. We have a mid-wall installation of the window. The over insulation we're talking about is having foam that wraps over top of the frame so that it actually seals this cavity in between.
And it just helps insulate the frame more. And also this is outside, by the way. So it's on the outside of the frame. So again, it's stopping the cold from transferring through where there's less insulation with the frame kind of thing. So it helps.
This is a good example. We did notice that the frame in the basement, which is the exact same wall and window assembly, it's just not over insulated yet. It's not quite finished. We were sitting just under 10 degrees in the basement and about 12 to 13 degrees, I believe, upstairs.
Yeah, well, I think it was showing 14 at one point, but the sun was on it. So yeah, probably around 4 degrees warmer with the over insulation.
Yeah, so it definitely makes a difference, especially when it's minus 35 outside.
Totally.
Every degree helps.
Yeah. Same with the patio door here. So the patio door is the 3 sides in the top, or 2 sides in the top, are over insulated, and the bottom is not. And again, there's a huge difference in the way that's performing. So now on the inside, you can see same thing. The window or the door frame with the over insulation is basically the same temperature as the other room there at 14 degrees. But at the bottom, we're definitely getting some thermal bridging with the flashing below the door. So that's going to be something that we're probably going to look a little closer at and see if we can come up with another strategy there to over insulate on the outside at least, if not on the inside as well. So if this is our floor and foundation assembly, we basically have, so that's our door. We have 2 inches of GPS that came right to the underside of the door frame. Then we have our deck coming off, and then we have 2 more layers of GPS down here. So for this transition here, what we did was we had a flashing vent that went, probably should use a different color for that. There you go. So it went under the door, across the face of that insulation, and down on top of the deck, just so we protected that styrofoam. But as you know, like we said earlier, metal's a good conductor. So we're having, with that flashing being under the door assembly, it's creating a bit of a cold transfer there, a thermal bridge, if you will. And so what we've come up with to try to rectify that is, if this is our hardwood, what we're going to do is take a piece of 1/2 inch foam, cut it on a sort of a wedge shape, and cut out that same detail on the hardwood. So we create a bit more of a thermal bridge there, or less of a thermal bridge, I guess, just to help protect the cold air that's being transferred through from that flashing, rather than uninstalling the door and removing that flashing. So we're going to try that first and see if that works. And if not, yeah, we may go as far as just uninstall the door and either cut this flashing shorter or come up with a different solution to protect that that insulation that's on the foundation there. So to be determined. So in this room, this is that Polycore wall we did. You can still see, like I said, where the metal studs are. So they probably show a little bluer because they're metal. They're going to transition a bit more of the cold air probably, but you can see the wall temperature there is 21 degrees. So this room obviously is not having any problems with keeping the heat in, since the thermostat is only set at 20. That bottom section there is where the metal flashing is installed for the Polycore system. But again, it's metal, so it's going to conduct the cold a bit differently.
And that issue we're noticing with the Polycore, the bottom of the Polycore assembly, is the way that the Polycore panels are installed. So this is our 12.5-inch panel. 12.5?
12.5.
Yeah. Our floor here, the panel sits halfway on the floor, so we have 6 inches on the outside, 6 on the inside. We also have insulation down here, filling the rim cavity, and then same thing going down lower. So everything is continuous. These gaps are not non-existent. Everything's touching. The one issue is the way that the Polycore panels are installed is on a metal track that goes all the way around. It's a good system. It's nice and solid. But because this is metal, even though we have no air leakage coming through, metal being a great conductor of heat and cold, that is showing up on the camera. You can't feel any drafts, but that is one of the compromises that we made on this one. And you definitely notice it when it's that cold outside. So
right. So there you have it. So this is the first of many, many videos to come. Like I said, we're going to go back. We're going to try to show real world stuff here in Calgary. So that, again, when people are getting into high performance building and products and techniques and stuff, they can actually find information that's local for us. Just because like we couldn't find anything. Like it was getting information from anywhere you could and trying it basically. So at least this way, we're maybe a little bit ahead of some people getting started. So we'll have some information, some insight, some things we tried that worked and didn't work. And then we'll have sort of some guidance for people who are just getting going.
We're also behind a lot of people and we're always willing to learn. So anyone who has questions or suggestions, feel free to come by and have a coffee and chat with us at some point. We're always trying to learn, and Absolutely. We're just trying to share our journey of trying to improve and do things better.
Continually building better.
Thanks for watching.
Thanks.